Hello everyone, welcome back. Here's vanAmsen. Today we are going to tackle a medium difficulty problem, longest arithmetic subsequence of given difference. So this is a great opportunity to practice dynamic programming. So let's dive right in. So here is the problem statement. We are given an integer array and a difference, and our task is to find the length of the longest subsequence in the array that forms an arithmetic sequence with the given difference. So let's, for example, have this particular array. So a subsequence is a sequence that can be derived from the array by deleting some or no elements without changing the order of remaining elements. So let's look at some examples. So given 1, 2, 3, 4, and the difference, let's call it D1. So the output should be 4. And it's because we can form the subsequence of 1, 2, 3, 4. So output should be 4. And if we have, for example, array of 1, 3, 5, 7, and D equals 1, then output will be just 1, because the maximum possible is just 1. But if we will have like 2, so for example 2, so if difference will be 2, then output should be 4, because we have a particular sequence of maximum length of 4. So now when we understand the problem, we will use a dictionary to keep track of the longest arithmetic subsequence ending at each element in the array in our implementation, and we will call the dictionary dp for dynamic programming. So now we will iterate over the array, and for each number we will check if num minus difference is in the dictionary. If it is, we can extend the subsequence ending at num minus difference by num. So we will update dp num to dp num minus difference plus 1. So if num minus difference is not in the dictionary, we cannot extend any existing subsequence by num. So we will start a new subsequence ending at num and set dp num to 1. So let's try to implement this logic. So first, initialize a dictionary to store the longest arithmetic subsequence ending at each element. So it will be dp dictionary, and then iterate over the array. So for num in array, update the length of the subsequence ending at the current number if num minus difference in our dictionary, then dp num equals dp num minus difference plus 1. Else, start new subsequence ending at the current number. So dp num equals 1. So it's a new sequence, and return the maximum length among subsequences. Return max dp value. So as you can see, the implementation is really straightforward and easy. So let's run it to see if it's working. But we should achieve quite efficient code. So let's run it and see how our code goes. So yes, and as you can see, So our implementation beat 82% with respect to runtime and 92 with respect to memory. So it's really memory efficient. And yeah, we have successfully found the maximum length among all subsequences. And there we have it. Our code works perfectly. And remember, the key to solving this particular problem is understanding how to use dynamic programming to keep track of the longest arithmetic subsequence. And I hope this tutorial was helpful. If you have any question, leave a comment below, and don't forget to like, share, and subscribe for more coding tutorials and challenges. Happy coding! See you next time.